Our next example is definitely an or statement. It has the word or between it. So we'll go ahead, solve this like normal. We will say we're going to divide by a positive 3, divide by a positive 3. Don't flip the sign. We're dividing by a positive. So y is less than 0 or y is greater than 5. That one was already solved for. So that's just fit one or the other. So I'm going to use an open dot on 0. It says y is less than 0, so I will shade to the left. Or y is greater than 5, so I'm going to shade to the right. Typical looking or statement. In this next example, we are going to go ahead and solve each of these inequalities. I have them written a little too big, or typed in a little too big, so I'll restart this. So it says c plus 7 is less than 4, or 7 minus c is less than 1. I will subtract 7 on both sides, and I get c is less than negative 3. Or, on this one, I will subtract 7. That's what creates 0, guys. This is minus 7. You do have a negative c is less than negative 6. You could have changed your sign to plus the opposite to make sure you don't lose that negative. Divide by a negative 1 on both sides. That tells me alarm's going off in my head. I've got to remember to flip the sign and divide it by a negative on both sides. And I get 6. So my answer is c is less than negative 3 or c is greater than 6. What's that look like on the number line? Well, I'll have negative 3 and I'll have 6 on my number line. I will put an open dot on negative 3. It says c is less than negative 3. Or, it has to just fit one or the other, greater than 6. So open dot on 6, shaded to the right. This last example, this is an and statement. Normally we see our and statements written as triples. This one's not. So in the end, we're going to have to write it as a triple. I'm going to go ahead and rewrite these two parts just so I can solve them a little bit easier. So on this first one, I'm going to subtract 7 on both sides. That gives me 2x is less than or equal to 6. Divide by 2, x is less than or equal to 3. I have the word and in between this for right now. On the second one, I need to add 4. I get 5x is greater than 10, and I'll divide by 5, which gives me x is greater than 2. So this is an and statement. How can I create a triple? Well, if you remember, we're going to put the smallest number on the left, the largest number on the right, put an x in between them. Now, let's figure out these signs. This says less than or equal to 3. So I'm going to place that sign just as so, less than or equal to 3. This one's a little bit backwards from what I have written here, but notice how it's pointing at the 2. It says x is greater than 2, pointing at the 2, so I'm going to make it point at the 2. There's my Pythagorean triple, and that does allow me to go ahead and graph this. So I'll put 2 on the number line, 3 on the number line, and I have this says that x has got to be greater than 2, open circle, greater than 2, and less than or equal to, colored in dot, less than or equal to 3. So it is the shaded region between the 2 and 3.